Welcome to another unit in this workbook, Statistics. This time I'm going to talk about what test theory is all about, how we actually conduct a test, what hypotheses are, and so forth. Well, as I said, we're going to start with the basics on test theory, and the basic is we need a hypothesis to actually test it. And there are two important aspects to consider for hypotheses. First off, hypotheses have to be falsifiable. So I need to be able to show that this hypothesis is wrong. And I have to keep in mind, I will never be able to actually prove a hypothesis true. Test always means that given the information we have, for the moment we could either assume that the hypothesis holds or we can falsify it. So it's always the idea that hypotheses are only working when they cannot be falsified, but it doesn't mean that they are proven, it just means they haven't yet been falsified. And there are two ways, or two types of hypotheses we work with. We first have the null hypothesis. That's a hypothesis which we actually test. That's a hypothesis which we try to reject or disprove. And we have the alternative hypothesis. That's the hypothesis we are actually interested in. Here we want to show that this is the best alternative for us. Well, since we cannot really prove something, what are we actually going to do here? Well, that's what we are interested in. So we're going to take what we are interested in. We're going to build the logical opposite of this, which is then the null hypothesis. That's also an important aspect to remember here. Our null hypothesis always results as the logical opposite to the alternative hypothesis. So we're going to take the logical opposite of what we are interested in. Then we're going to test this opposite. We're going to test the null hypothesis. And ideally, we can reject the null hypothesis. So if the null hypothesis does not hold, then necessarily the logical opposite needs to hold. The logical opposite is what we actually wanted to show. So if we can reject the null hypothesis, this means that the alternative hypothesis should be the correct one. However, each rejection of the null hypothesis goes hand in hand with an error margin. So we always might make an error when rejecting the null hypothesis. And that's why we try to keep this error as small as possible. Well, this means we first have to learn what are errors. That's also part of this, session or unit. However, before we get there, I want to first introduce different types of tests. And here we have two-sided tests. And the importance of the difference of the two or one-sidedness of test is it impacts how the null and the alternative hypothesis looks like. Because with two-sided tests, we're testing whether a difference exists between the empirical and a theoretical value. So here we're working with equality versus inequality. Null hypothesis usually is the equality, alternative hypothesis the inequality. On the opposite, we have the one-sided tests. Here we want to know whether the empirical value is larger or smaller than a theoretically given value. So what we're going to do here is the null hypothesis is smaller or equal to, the alternative is larger than, or the other way around. So here it's always about small or larger. Here it's about equal or unequal. And well, as I said, that's something which impacts the hypothesis building as such, and that's why I did this before talking about errors or anything else. Well, then we can talk about errors. The error we are mostly interested in is the so-called alpha error. The alpha error is the error which still persists if we reject the H0 hypothesis. So that's actually the error we want to have as small as possible. Whereas the better error, that's the error we make if we retain H0, even though H1 might have been the correct alternative. So that's also an error we want to keep as small as possible. But the downside to all of this is if we decrease the alpha error, the beta error will increase. And if we decrease the beta error, the alpha error will increase. So there's no good way to actually pushing down both types of errors. But it has been found out that with a significance level of 5%, so an alpha error of 5%, they are as small, or their sum is as small as possible, and they're almost equal. So it's actually a good trade-off to always work with a significance level of 5%. And well, should the alpha error then be smaller than 5%, so even if it's very much smaller than 5%, that's not a tragic situation. But it should be at least 5% because then it works out well. We could also determine different other values, names, denominations for the different types of errors. But before we get there, well, why is the alpha error actually the most critical error? Well, if H0 is correct, we could have two situations. We test, we decide for H0, that's good. If H1 is correct, we test for H0, we decide against H0, that's also correct. So no problem in those two cases. The only problem results if those two situations actually take place. So in other words, if we assume an effect, but there is none, or if we assume there is no effect, but there is one. And of those two cases, this one is actually the most critical. So there is no effect, but we assume that there is an effect. So in this case, that's the one we try to avoid. That's why we call this alpha error or type 1 error. The other one, it's also not nice that we actually have an effect, but we just overlook the effect. It's not this nice, but it's not as hurtful, possibly hurtful, than the other one. So that's a more critical one. And as I said, that's the probability that H0 is correct, or rather that's the error we make if we reject H0. And if you work with a statistics program, usually you do not find anything on alpha errors or on type 1 errors or whatever. You usually find something on p-values or significance levels. And that's exactly the same thing. So those 5 different names, descriptions, actually mean exactly the same value. And well, that's then everything there is on this introduction to test theory, on the different terms which come up in the context of a statistical test. So I hope you enjoyed this short session. I say goodbye and see you next time.